Hi everyone, I'm Scott Delandy, part of the product management group with the Dell EMC storage division, and I'm here to talk to you today about PowerMax. And what we want to do during this session is we want to talk about some of the new capabilities that we've introduced recently with the platform, but we also want to share with you some of the cool new things that we're planning on introducing in the not so distant future. So with that, let's go ahead and get started. So first off, when you look at PowerMax today, from an architecture perspective, it's still based on a multi-controller scale-out design. And what users really like about that is the fact that they can start small with what they need from a capacity and a performance standpoint, but then they can very efficiently and cost-effectively be able to scale out to meet future growth requirements. We've also built in a number of new hardware-based features into the system with PowerMax. Two of the big ones include, number one, new data reduction technology that allows us to do deduplication and compression. Combined, we see easily a 4-to-1 space efficiency for most applications and workloads that run on a PowerMax system. But the other part of the big news is the introduction of NVMe technology on the back end. The drives that we're using today are solid-state drives. We're an all-flash array, but the types of drives that we're doing are very different than other platforms out there in the marketplace. We're actually using dual-ported NVMe drives, the first and only system available today that takes advantage of that technology. The benefit is the ability to have more performance, lower latency, and more throughput in I/O for that platform. Hold on to that thought because we're going to come back and talk a little bit about what that means today, but more importantly, some of the things that we'll be able to leverage with those capabilities in the not so distant future. From a management perspective, we're all about simplicity. Matter of fact, if you were using a symmetric system or an older VMax system, even 3 or 4 years ago, your biggest challenge moving into a PowerMax is not to learn anything new. It's really to unlearn all of the things that you know about those older platforms, because the way it's managed, the way it's administered, just the automation that we've put into that platform really changes the way that that system is actually used and administered in an environment. It's one of the things that our customers really like about the new technology is the simplicity and the automation. One really new cool feature that we've introduced is a Cloud IQ, which is a web-based portal that allows us to do reporting in the environment. What people like about it is that it's available as a mobile app. So if you're interested in friending your PowerMax system or your VMax system, you now have the ability to do that with Cloud IQ. We're also working on pushing innovation with the platform as well. This is an area that we've always focused on very closely from an engineering perspective, and we continue to add new capabilities and new automation into the system. Machine learning is really one of the big differentiators within the platform. The ability to understand workloads that are running in the system in real time and to be able to react to what's happening to make sure that we're completely optimized from a performance and a capacity standpoint. We'll talk a little bit about that in another few minutes. And we're also tightly integrated with lots of environments. Specifically within VMware, we have a ton of integration. We're able to support a number of APIs and offloads that just make it very easy and very efficient to be able to manage virtual environments, especially at large scale. So let's spend a second and talk about NVMe, okay? What you see here is the orange line, and that orange line represents where most storage systems are today. From an all-flash perspective, they have flash drives that they're using, but they're using an older storage protocol to connect to that media. So when you look at just the I/O and the latency to those drives, you're looking at about 200 microseconds to read and write data to the flash, okay? And you're looking at throughput of hundreds of megabytes per second, okay? Which is really good today, but really doesn't take advantage of what's possible with the flash media. If you look at the blue line, that's where PowerMax is today. Those are the NVMe connected flash drives that we're using. So what you see here is about a 50% reduction in latency to those drives. So what used to be hundreds of microseconds is now about 100 microseconds. So that's much faster, much lower latency, able to support your really response time sensitive applications and workloads. We're also able to double the throughput to those drives, going from 100 or so megabytes to a couple of 100 megabytes per second. So I can push more I/O, more workload, and I can have a higher I/O density with fewer flash drives in the system. So that's what we're delivering today with PowerMax, the blue line. Where we're going in the not so distant future is the green line, where we're planning and working very closely now with Intel on their storage class memory technology, something that you've heard out in the marketplace referred to as the Optane drives. We're actually working with Intel very closely to test and qualify a version of the Optane drive that's designed for our systems, takes advantage of things like dual porting on those drives to be able to give us even more performance and higher resiliency and be able to take advantage of the capabilities that we're leveraging within the system. Now, when you look at the storage class memory drives, one of the things to be aware of is that they are a premium because of the performance that you're able to deliver with that technology. So while it may be a fit for applications that are very active and can take advantage of that level of performance, it's probably not cost effective for all of the applications or for all of the data sets that you have in your environment. So one of the things that we're looking at doing is being able to take a look at how those workloads are performing, where are the active data sets, and how do we make sure that those active data sets are placed on the highest performing storage class memory Optane tier, while taking the less active parts of the data sets and putting those on the efficient, cost-effective flash with all the data reduction, compression, and dedupe being able to apply to that. The result is the ability to leverage the performance of storage class memory, but also being able to do it at an extremely attractive cost point. And what we're seeing is that only a little bit of storage class memory is required in order to be able to get a tremendous bump in terms of performance. And we're actually going to show you what that looks like today. So the value of this is really in not just the hardware or the media types that we're using. From a PowerMax perspective, it's in the intelligence that we've built into the platform. So from an administrative perspective, you don't have to worry about what's active, what's not active, and what happens when those workloads begin to change over time. The system does that for you, so it automatically optimizes the placement and the movement of that data across the different tiers. So now what I'd like to do is actually show you a demo, okay? What we're going to do is we're going to take you through the ability to leverage storage class memory on the back end, but also in combination with NVMe connectivity off of the front end. So to help me do that, I have James Celona, who's one of our corporate systems engineers based out of corporate in Hopkinton, and he's going to take us through that. So James, what are we looking at?
Thanks, Scott. So we're looking at the all-new Unisphere for PowerMax here, and the demo I want to show is using storage vMotion to migrate from traditional fiber channel to NVMe, fiber channel over NVMe.
So what are we running inside of the system?
So inside the system, we're running a new version of the PowerMax OS, which is the PowerMax operating system. We have some custom vSphere code and custom ESX code, obviously.
So these things aren't generally available today. We're doing more of a tech preview of what we're planning on introducing next year.
Exactly. We want to give everyone a little sneak peek of what's going on.
All right. Show us what we're running for capacity or for drives in this system.
Absolutely. So we'll jump into the system and we'll look at storage. And I want to go to the storage resource pool. And if you don't know what that is, it's really just a logical configuration of all the disks we have available.
Okay. So I see the pool there.
Exactly. And if we go down here, we see there are 2 disk groups.
Okay.
We want to dive in a little deeper and understand what those are. We have 2 disk groups in here right now. We have what we have available now, which is our NVMe-based SSDs.
Okay.
And we also have the all-new Intel Optane drives. So these are these SCM drives that Scott was just mentioning. And these are incredibly fast. We're getting a lot of performance out of those. And again, these are the dual-ported drives.
Sure.
That have the throughput available.
Right. And so, but most of the capacity is the traditional flash capacity. So we just have a small pool of Optane capacity in the system.
That's a very good point. Now we can go and talk about service levels.
Okay.
Because we have this machine learning and we are understanding how the data is. We don't need a giant SSD. You don't need that giant SCM tool.
So with just a little bit of Optane technology in the system, we're showing a diamond service level today that's 0.4 milliseconds. Exactly. So if it was just all regular flash, if there's such a thing as regular flash, the target response time for diamond is 0.6. So just by putting in a small pool of storage class memory into the system, we're reducing the latency system-wide, reads, writes, everything with all the data services, dedupe, compression, encryption, snapshots, by about 30%.
Exactly.
Half a millisecond.
Not bad.
That's cool.
All right. So now let's jump over to vCenter and take a look.
Okay.
So we have the vSphere here again. This is a custom build. So if we take a look at the available data stores, we have a couple here. What we're interested in is the fiber channel one we have right now, and we also have the FC NVMe data. So
we were just looking at the back end of the array, showing the fact that we had flash drives mixed in with storage class memory. Now we're looking at the other side. We're looking out the front of the array, and we're connected on fiber channel, but one we're using traditional fiber channel protocol. The other one, we're using NVMe as the protocol, but we're also running that over fiber channel.
Exactly.
Very cool.
So if we take a look at the configuration, just to show that again in a different way, we have a couple of storage adapters here. The one we click on right here, this is the fiber channel one. So this is the traditional storage storage adapter we've always had.
Yep.
And we take a look at the other one. This is the NVMe one, and we can see we have the NVMe data store. Again, that's that PowerMax device. Right, that is the.
But this is the same SAN fabric. The difference is on one connection we're running traditional fiber channel, and the other we're running NVMe. Why is that important to a user?
Oh, it's huge because we don't think everybody's going to go all in on NVMe immediately. We think they can take advantage of it over time. So they have some traditional fiber channel SAN,
right,
and they can slowly introduce it into the environment.
So as they look to refresh the environment, they'll take their performance-sensitive clusters and applications, and they'll move those first to NVMe, running directly from the host all the way to the back-end storage.
Exactly.
Got it.
All right, so now let's go to this Linux VM, and what we want to do, like we talked about earlier, is let's just do a storage vMotion.
Okay.
So we check out the data store right now. We're on that fiber channel data store that that's been running.
Yep.
We use actions, go to migrate. Go here, we're going to have what we've always seen before. We just do a standard storage vMotion.
Sure.
Nothing's going to change here. This is what people have been doing for years.
You're going to hit the button.
Hit next. Yeah.
Now we're moving it. So we're moving the storage group from the traditional fiber channel over to the NVMe fiber channel.
Exactly.
Awesome.
So we click on that data store right there. Okay, everything checks. The checks pass. The last step is just to review and finish. And we'll see within seconds this is going to migrate over there.
Done.
Perfect. Non-destructively easy.
Very, very cool. So two key things, right? Again, storage class memory. You'll see us introducing that in the not-so-distant future. And NVMe fabrics.
Exactly.
They are the future.
Exactly.
All right, cool. James, where can we go for additional information?
You need anything else, you go to DellEMC.com.
That's it. All right. Thanks for joining us today, and we'll see you soon.
Thank you.
Boom.
Boom.
All right. Are we off? Okay. That didn't stop.
Until I come back and take it off you.
Yeah, just do it like that. Should be fine.
So Val will give you a 3, 2, 1 countdown.
Yep.
And you're on. If you're still going at 10 minutes, we'll give you a 2-minute warning.
Yeah, I saw that.
All is good.
All's good. Hello, test 1, 2. Okay.
Well.